Hello, I want to talk to you, College Algebra. I want to talk to you about the properties of logarithms. Logarithms are cool. They have this special property. Now, when I write this property, I can write it for any logarithm, any base. So there's the common log, base 10. There's the natural log, ln, base e. E is just a number, There's all log base 3, log base 2, log base 7. There's all kinds of logarithms. So when I write this, I could do it for any logarithm. I'm gonna use ln. It's shorter. So here I go. So the ln of an a times a b. Logs have this special property, all logs, but the natural log has this special property also. That is, I can take the log of a product and bust it into the sum of two logs. So I can make this the natural log of a plus the natural log of b. The log of a product and bust it into the sum of two logs. You don't do that. This is weird, kind of. You don't do that in mathematics much. I mean, you don't do that with square roots. You don't do that with things Anyway, here's another property. The natural log of an a divided by a b. So it's one natural log of a quotient, a divided by b. And guess what you can do? I bet you can guess. You take the natural log of a and you subtract the natural log of b. There's one more. I consider this the most important one here, but it's the natural log of something raised to a power p. So there's an exponent on this a. And the property is you're allowed to take that exponent and bring it down front and multiply it. So it's p times the natural log of a. So you can use these properties forwards or you can use them backwards. I mean, if you have this, you can go back to a product. And the exercises that are in the book and in the practice kind of make you practice using these properties. Some typical exercise is this. The natural log of x squared y cubed over z to the fifth. It's a z to the fifth. And again, I did natural log. So it's the natural log of this quotient, product, x. I mean, this is a mess here. Well, I can use all three properties to bust this up. They don't say bust it up. They say rewrite this logarithm as a sum or difference or product of logarithms. So here we go. I think this is kind of easy, but you can, that numerator is multiplied, so I can rewrite that as the natural log of x squared plus the natural log of y cubed. I'm rewriting that, and because the z to the fifth is being divided by z to the fifth, that's in my denominator, I can subtract the natural log of z to the fifth. So I sort of did property 1 and 2 all in one move there. I took that product, made it a sum. I took that division and made it a subtraction. And now I can use property 3 that says I can move these exponents down front. So I can rewrite this as 2 times the natural log of x, 3 times the natural log of y, minus 5 times the natural log of z. And I'm done with this problem. The question was, please bust this up. Use the properties of logarithms to bust this up. They could also say, please use the properties of logarithms backwards to put this back together and rewrite it as a single logarithm. That's a different problem. So then you would put the 2 back up. You would do all this in reverse. These properties work forwards and backwards. That's what an equal sign means. So you could put the 2 back up, the 3 back up. If you had this expression, you could put it like this. You could take that product, that sum, and write it as a product. You could take that subtraction and put him in the denominator and rewrite this back as a single logarithm. So these are exercises that make you try to use these properties. These properties are useful when we solve equations. So I haven't got there yet. I want to tell you about another one. There's this change of base formula. Change of base formula. Not a real fan of this, but it's okay. It's helpful. If you're trying to do the log of base, log base 8 of 64, I kind of don't need the change of base formula. I think I can kind of do that in my head. I'm looking for the exponent that you put on 8 in order to get 64. I think the answer is 2. So some I can do in my head. And if it's log base 10, it's a button on my calculator. And if it's the natural log, it's a button on my calculator. So I use my calculator. And nowadays there's some fancy calculators that allow you to punch in any base you want. But let's just say you don't have that and you were trying to do the log base 17 of, no, that's crazy. Let's do the log base 4 of 25. So I'm looking for the exponent. You put on 4 in order to get 25. You know, that's not a perfect number. It's going to be some decimal. It's going to be some decimal. I mean, 4 squared is 16. 4 cubed is 64. So it's somewhere between 2 and 3. But using the change of base formula, I can do this. I can rewrite this as any logarithm that's with any base I want. And I would pick something that's definitely on my calculator, like log base 10 or the natural log. It's definitely a button on my calculator. And here it is. It's the same as this. The natural log of 25 over the natural log of 4. I just changed the base. It was a base 4, and I've changed it to this natural logarithm, which we all know is base e. Yeah, if you do this, you'll get the answer. But again, you punch this in your calculator, you punch this in your calculator, you divide them, be careful, and you get the answer. Like I predicted, I think it's 2 point something. Let me just try this one. The natural log of 25 divided by the natural log of 4. We're using parentheses, trying to be careful there. I'm getting 2.32. This answer is 2.322 if I round it to the third decimal place. So that's the answer, using the change of base formula. There, let me officially write that change of base formula for you. The change of base formula says if you have the log base b of any x, you can change it to any base you want. You've got to make it the log base a of x over the log base a of b. You're changing from a base b to a base a. And by the way, you shouldn't just pick any old a. I mean, you can. That's what the rule says. But you pick one that's famous and useful and on your calculator, like base e, the natural log, or base 10, the common log. All right. Good luck.